Hey guys, welcome to my video on C# delegates. In this tutorial, I'm going to show you what delegates are and how they're used. If you search online, you will stumble across multiple videos that give you more or less the same information I'm about to, but I've noticed that a lot of them gloss over the keyword delegate and why you should use it. And they immediately jump into the delegates provided by .NET. So in this tutorial, I am going to show you the delegates, the provided ones, but then I'm going to end back on the delegates so you can have a clear idea of when do you actually want to use one versus the other. So with that being said, first of all, what is a delegate? A delegate is a function pointer that is type safe. That is the simplest terms. So if you think of JavaScript, it's a callback function. In C++, they also have function pointers. The key difference is that in C#, it is type safe, meaning you have to give it the params and the return type. And you can't really just pass in whatever you want. You're set to whatever it is you assign the delegate to be. So without too much detail, let's go ahead and jump into this one application. And for this one demo, I have a screenwriter that it's going to have a bunch of methods. So let's just say public void display message. Okay, and this is going to take a string message, and we'll say console.write line, and we'll just write the message. Nothing fancy here. And we're going to create another one, public bool check if hello. Oh my god. Check if hello string message turn message equals hello. And then we'll say public string return message. All right, so I got these three methods that I want to invoke from a delegate. So let's go ahead and create the delegates to do it now. You know, technically you could just do it this way, screenwriter that display message and call it. But let's just for this scenario, let's actually invoke it from another function. So we'll say static void, and we're going to execute the first one. So we're actually going to say static void execute action. Okay. All right. So what we want to do is we want to pass this method into this execute action. So how do we do that? How do we map this into something that we can put as a parameter here? Well, that's where a delegate comes into play. So we're going to say public delegate. So this is just assigning a delegate. This is just creating the signature of what a delegate is. Kind of like whenever you create an interface and you provide the method, the signatures of the methods that the interface has, kind of the same idea. So in this case, if I want to map this method into this delegate, what I would say is public delegate void. It returns void, just like this one. And then I'm just going to give it a name. So I'm going to say my action, and this can be whatever you want. And then it takes one param. So the only things I have to match is the return type and then the params. So in this case, I'm going to say string message. Okay. So now if I say my action, all right, I can say my action and pass it in the message. Let's say hello. All right. So if we invoke this now, we can say execute action. So we call this a method. And that method is going to be this display message that we spoke about. So when you pass it in, you just pass it in. You don't open curly braces. You're not executing the function. You're just passing in the function as a reference. Okay. All right. So this would then pass. So this method passes this method here, which then gets executed down here. All right. So let's now do the same for this predicate here. So we're going to call this public delegate. Now this is a Boolean. and we're going to call it my predicate, and takes a string message. And also the name doesn't have to match, so this can be message 1, for example. It doesn't have to match whatever is on the method. So we'll just say, let's call a method here to invoke it static. We'll execute predicate, my predicate, and then we'll bool result equals my predicate. All right. So again, we'll call this method here. Check if hello, and that's the one we want to pass in. And last but not least, we're going to do this function here. So public delegate, and it's a string, and then we'll say my func, and it takes in a payload, string type of payload. And notice that I'm not using the same names. It doesn't care about the names. It's just, again, the types, the parameter types, the same count of parameters, and then the return. So static void execute func, then my func here, and we're going to say bar message equals my func hello. Okay. All right. So execute return message. All right. So now we've created 3 delegates to match the 3 methods that we actually want to pass in. Okay. So let's go ahead and make this a little more exciting. Let's make this generic. So for example, instead of just saying, my action, just take a parameter of string, what we want to do is we want to make this flexible to return in whatever you want. Let's say my action can take an integer instead. So for that, we're going to provide a generic of type T, and we'll pass it here. So if you're familiar with generics, then obviously you know what's going on here. And we'll just say string, okay? And now everything works the same. We'll do the same for the predicate of type T, All right. And then for func, we have to say, hey, well, this takes in 1 parameter and it has a return type. So we'll do T and then T result. And it doesn't have to be T result. It can be, T result foo, whatever it is you want it to be. It's just usually by convention, you just type in T result. So we'll use T result here and then T here. Okay. And so instead of my func, so we know it's a string and return say string. Okay. All right. So that's good. So now you can see how we just created our own funcs that are generic. So we create an action, a predicate, and a func. All right. So now .NET actually provides the same delegates for you, so you don't have to do this here. And they also have overloads. They have up to 16 overloads for each, so where you can have multiple payloads. So you can have T and then T1, for example, and that would go here as T1 payload, right? So you could have string, etc. So this just means it takes 2 parameters of whatever type, and then it returns a and has 1 return type. Okay. So in each overload, the last one is the return type. Anything before that is just how many params you want your method to have. But let's go back into our regular function. Let's remove all this. All right. So now, if we wanted to use .NET built-in one, I'm just going to simply remove the my action. So if I remove it, notice everything still works. It still says action, no red lines. So I'm going to do the same for predicate. So again, .NET just gives you the predicate, and then I'm going to use the built-in one, which is func, which .NET gives you. And now I'm just going to remove this ones because we no longer need them. So far so good. You might be asking yourself, well, if .NET gives you these three ones, plus there's another one that's called events. We're not going to touch events. I think I already said that, but um, if .NET gives you those, why would you ever actually use the delegate? And this is a question that I hear the most. You know, if I don't have to do all that syntax where I have to initialize it, why? So for this, I have this quick little registration repo here. This is just a test. Essentially, it takes a token, and depending on the provider, the token might be formatted differently. For example, uh, the property for last name might be called last name, or it might be called family name, or something else, right? It could be whatever property represents last name. So what we want to do is we want to provide a function to let the actual token parser for each service determine, hey, this is what a last name is, for example. But when we wrote this, notice that we're using the same syntax, func of auth token property, string, and then the name of your delegate. This is a little bit harder to follow. So let's go ahead and clean it up. So we'll say public. Okay. So this takes a string. So it returns a string. So we say public delegate string, and we'll say get user name delegate. So we'll use the del. That's by convention. You always add the del at the end so people know that it's a delegate, except for the actual, the action, predicate, and func. Those are just well known, I guess. And this takes auth token properties and properties. All right. So now we can rewrite this by simply saying, oh, whoops, get user del, get user del. And I don't know about you, but this looks much cleaner to me. And if you have to update the interface as well, so we'll update it here. All right. So now get user del. Okay. So now you clean all that in here. Okay, it looks cleaner, but let's see where else it would look cleaner. So if you go into, I have this mock repo. Now let's create a mock for that one. So if we say mock equals new mock, get user name del. Okay, look how much cleaner that is. Now let's write it the old way. So if you say bar mock, let's say one equals new mock with the function syntax. Notice how many funcs we have to use. So auth token properties. So this is just so much harder to just read and write. Imagine doing this over and over and over again. It gets worn out by the opening braces, and I usually miss, like, I'll usually have this, for example, once you do your mock and you want to check it that is any, for example, right? So if I can say it that is any of get user del, right, that's not too bad, right? But if I have to do it that is any uh, and then the func, and then other it that is any's, that's when things can get just really messy, just really hard to read, because you'll have comma, another it that is any over here for like the actual properties, etc. So you're not just doing it on the creation of the mock, but also on the whenever you're verifying or on the setup of the mocks, you have to always provide this thing. So this is much readable. And for as the last thing, real world scenario, in one of the projects that I'm working on, we actually have injected a func of I, what is it, of type comma I log, and this is a logger factory. And we use this syntax literally in every single class because we're passing in the logger to every single domain object, class, service, repo, etc. And whenever you want to mock this, you also have to use the syntax for the mocking part. And it just gets really, really hard to read. So one way that we could fix this rather quickly and just make it so much easier on ourselves is just by creating a public delegate that returns ilog, and we're just going to call this, logger factory. And this logger factory takes a type, and this is the class type. Okay. And the way that you execute this, by the way, is you say ilog logger equals, logger factory get type. So now instead of writing all of this, look how much cleaner this becomes now by just saying, hey, well, you got a logger factory, right? Obviously, it's good to put the del here, so we'll just put the del. Logger factory del. And this is it. This is much easier to read, much easier to mock, and overall. And this is a real world example. Like we have this in our dependency injections, and we solved it slightly different. We actually created an interface for it and extracted it all out into our own custom login interface. So that way, if we change the logger, we can use whatever we want. But in other places, as a quick one, we could just create the delegate instead and just remove all the funcs from those places. So with that, this concludes the video, and I hope you guys were able to follow along. So see you later.